Greetings, citizens of planet Earth. Welcome back to another episode of the Mystery Dome. Today we will be talking about very large numbers. Now this is more of a math thing than a science thing, but it's still a very interesting topic that I would like to explore. So, of course, there are some numbers that simply are very large, of course, but it's sometimes underestimated how large they can get. I know in school pretty early on we learned that there's an infinite number of numbers, but we kind of just set this aside and don't look at how big numbers can actually get. Now the first number I'd like to talk about is a googol. And a googol is 10 to the power of 100, a 1 followed by 100 zeros. Now, a googol is a very large number, but it's still writable. I mean, it's reasonable to some extent. It's something that you can mathematically use if we're talking about something very large or something very high dimensional. But one step up from this is a googolplex, and a googolplex is a 1 followed by a googol zeros, so 10 to the power of 10 to the power of 100. Now that is a number so large, even if you used every atom in the universe as a zero, you still couldn't write it down fully. And that's where we start to get into the unreasonable, purely imaginative level of stuff, because you can't even write this down with every particle in the universe. But we're barely getting started. The next is a googolplexion, also known as a googol triplex, which is a step up from the googolplex. It's 10 to the power of 10 to the power of 10 to the power of 100, meaning it's a 1 followed by a googolplex zeros, which is so many layers of zeroception that it's barely even imaginable. But the main number I would like to talk about is Graham's number. And many of you know what Graham's number is if you're a fan of Numberphile or something like that. But for those of you who don't know what it is, take the base of 3 and imagine just cubing it so that 3 to the power of 3. So 3 to the third power is where you start. This equals 27. Now, there's an easier way of writing this. So, just like how multiplication is a step up is repeated addition, and exponents are repeated multiplication, this notation called up arrow notation is one step up from exponents, repeated exponents. So meaning that 3 up arrow 3 is 27, which is the easier way to do things. Now, what about 3 2 arrows 3? Now this would be significantly larger. It'd be 3 up arrow 3 up arrow 3. So it would be 3 up arrow 27. So it'd be 3 to the 3 to the 3 to the 3 27 times, and that's 2 hours 3. Now we're barely getting started. 3 arrows 3 is even more inception, because it's 3 2 arrows 3 2 arrows 3, meaning 3 2 arrows 3 to the 3 to the 3 to the 3, 27 times. And we have an incredibly large number from that. And after this, we just start to get into ridiculous territory. So, the first real step in Graham's number is 3, 4 arrows. 3. And this is 3, 3 arrows. 3, 3 arrows. 3. Meaning it's 3 up arrows, 3 up arrows, 3 up arrows, 2 up arrows, and 3 to the 3 to the 3 to the 3, 27 times. Now, a number like this is something that is barely imaginable by human brains. And this giant number that's barely imaginable is simply known as G1. G1 is the first step in Graham's number. It's also called a grawl, and you see that it being referred to that very often. Now, here's something even more frightening. 3 arrows. So there are a G1 number of arrows. So just that number that we did here, now there's that number of arrows between the 3's here. And that's a super large, unimaginable number. And this number, this unimaginably large number, is known as G2. G2 is also called a Graham grawl. It's also referred to that in some texts as well. Now, to get to G3, it's a 3 up arrows. And again, there's a G2, a Graham grawl number of arrows between the two numbers. And this creates G3. Now continue the cycle until you get to G64. In G64, the end result of all of this is Graham's number. Now, you may be asking by now, what is the relevance of Graham's number? Well, it's simply a number to indicate the number of dimensions in which a certain pattern of vertexes and lines can exist in a shape of that dimension, and G64 is the maximum amount, the maximum amount of dimensions that this can exist. So, yes, Graham's number is the main number I wanted to talk about, but there have been even larger numbers, such as Rayo's number, which has been famed to be the largest number to ever be conceived of. It was created in a contest where some people would try to create the largest number they could, and one guy just went over the top insane with his answer and created a number that makes Graham's number look like, I don't know, an ant compared to what Rayo's number is. Currently it's so big that modern computers, even like supercomputers, can't compute that. That's how large it is. And there can still be larger numbers. You'll never run out of new numbers. And it's such a concept that you'll always have a bigger number to find. And I say very large numbers, but in the grand scheme of things, these are teeny tiny little things. They're just the things that we consider large because we don't encounter them very often. And this kind of segues into the topic I will be talking about next week, which is infinity, and which is more of a concept, but the concept that nothing ends is essentially what that is. But I would encourage you to look at some of Numberphile's videos. They talk a lot about these large numbers. There's a video by another YouTuber, Spoonies, who made a video about very large numbers that began with a Google and went up all the way to Rayo's number. And yeah, go check that stuff out if this interested you. So I will see you next week. We will be talking about infinity next time on the Mystery Dome. Goodbye.